Have I seen the Fermilab video on why light slows down in a medium? Yes, I have, and by the way, shoutouts to Fermilab, you should all follow them on the Red Play Button app. And it's entirely right, and I'll explain what it's saying right here. So colloquially, when we talk about light being slowed down, we usually end up getting to a point where people ask, how does it slow down? Because we have relativity, right? Relativity says that anything without mass has to move at the speed of light. So inevitably, someone ends up asking something like, well, if light is slowing down, does it have mass? Or does this mean that we can slow down light to break the speed of light, or something like that? And of course, the answer, for the most part, is no. So then what's happening? Well, a very basic but also wrong explanation is that light is bouncing around off of the atoms in a medium, or light is getting absorbed and re-emitted by atoms in a medium. I want to note, it is doing that too, but that's not why it is slowing down. That's why a certain amount of light scatters, but that scattering isn't why the light slows down. Light slows down because it's not just a particle, it's a wave. It has a certain wavelength and a certain velocity, and that velocity is always c, the speed of light. Now, any medium is also going to have an electric field generated by its electrons. And that electric field is basically an electromagnetic wave, just like light. It has a speed and a wavelength as well. And when two waves of the same type interact, basically you can add them together. So you get this electric wave of the medium, which has a slower velocity, and this electric wave of light, which has a velocity equal to the speed of light, and you add them together, and you get a velocity which is somewhere in the middle. Still very much close to c, the speed of light, but less than it, somewhere in the middle. But the key here is that this additive wave isn't just light, it's combining light and another wave. Light is still moving at the speed of light, but the other component of this wave is moving slower than the speed of light, and so combined, the waves move at a slower speed than light. But as soon as light exits a medium, the wave of that medium is removed from that additive wave. And so it looks like light speeds up again. But there is no speeding up or slowing down happening, because that would take energy. A portion of that combined wave that was light was always moving at the speed of light. And so when you take away the portion of that wave that was the electric wave of the medium, light just continues moving at the speed of light. So you're not really adding energy to speed it up, it's just continuing at the speed it had to be moving the whole time, because you're removing the other wave that's interfering with it. So that's what's really happening when light passes through a medium. But because people struggle to think of light as a wave, and similarly struggle to think of waves adding together, the analogy that is often used is that it bounces off atoms, because that's atoms interfering with light, which is essentially what's happening. It's just not happening in that specific way.